So finding sums is pretty easy. However, if I asked you to find the sum of 30 terms, 40 terms, 50 terms, that could be a very tedious process. So there's formulas depending on the type of equation you have to find the sum of that you can use. And I'm going to start by showing you the arithmetic formula for finding sums. Now, where did this formula come about? There's this whole theory, I don't know what it's called when it's like this talk in the math world, that the mathematician Gauss was a troublemaker in school. So this is like story time with Mrs. Schmer. That this mathematician Gauss was a troublemaker, and his teacher got very upset with him. So his teacher said, Gauss, I want you to go in the corner and I want you to count the numbers 1 through 100. And she thought she was going to fool him. She thought, you know what? He's so bad. I'm going to give him something to do that's going to keep him busy for a long time. And the whole rumor is that, like, 15 seconds later, he came back with an answer, or super quick, maybe not 15 seconds, but within, a couple minutes, he had an answer for her. And she was like, wait, what? Like, how did you get the answer so quickly? So if you look, this right here in this color shows you how he got the answer so quickly. If you think about listing numbers that are arithmetic, that have a pattern, you're going to notice that when you take the first number and you add it with the last number, you get 100. If you take the second number and add it with the second to last number, you also get 101. If you take the third number and the third to last number, you keep getting the same exact sum. And this continues on for a certain number of times. Now think about how many times this would happen. If you have to add 100 numbers together, you're going to have 50 sets of 101. So if you take the sum of the first number with the last and you multiply it by the total number you're adding together divided by 2, you would get the sum of that quantity. So if you look, that's exactly what's stated in this formula right here. If you want to find the sum of the first n terms of an arithmetic series, you are going to find the sum of those terms by taking the total number of terms, so n is the total number of terms, which in the last problem was 100. You're going to divide it by 2, and the reason you're dividing it by 2 is because that's the number of sets of that quantity you're going to get, because we're pairing those numbers up. And then you're going to take the first term of that specific series, and then you're going to add it with the last term of that specific series. So keep in mind that a sub n, let's just say it was a sub 100, you would put in that 100th term. So this is the formula that we're going to be using whenever we're dealing with an arithmetic series. So remember, arithmetic needs to have that common difference for each term, so as you go through the sequence or series. So looking at question number 9, you're going to see on this problem right here, we are constantly adding 7, adding 7, adding 7, adding 7, and so on and so forth. So as a result, this is arithmetic. Now, of course, you could do this by hand. So I just want to show you how this formula does in fact work, even if you didn't use the formula. And let's go to just adding them all up in general. What we can see is a couple ways you can actually think about this one. But you could take the -8 plus the -1 plus the 6 plus the 13 plus the 20 plus the 27, and oops, that's going to be our answer. Now, another way you can think about this is pairing up the numbers. If you think about what is -8 plus 27, kind of going along with Gauss, you're getting a sum of 19. Notice you get that same sum here, that same sum here. Do you see how we get that sum of 19 3 times? And that also gives us that answer of 57. So using this formula, you basically would take the total number of terms. So we have 1, 2, 3, 4, 5, 6 terms. So the sum of 6 terms, you would take the 6 divided by 2, which gives us that 3. And then you take the first term plus the last term. So notice these are three different ways of doing the same thing. You can add them all up if it's a short series. If it's not, you can use Gauss's idea, which really comes in with that formula. So kind of cool that you can see all the connections there. Now, I'm obviously not going to do that for number 10 because on number 10, it says find the sum of the first 10 terms. It only gave me 3. I don't know if I want to take my time to list all of those values. So if you're ever given a situation where it said find the sum of 10 terms and you don't have all the terms, or even if it said 30 terms, 40 terms, remember that we need to check to see if this is in fact arithmetic. And notice that I'm adding 3 to go from term to term. So if that's the case, if I want to find the sum of 10 terms, I'm going to do 10 divided by 2. I need to know the first term, but then I need to know the 10th term. Now, for some of you, you may say, I'd rather just add 3. But remember, we have a formula for finding any term in the series. You're going to do a sub 10 equals the first term plus n minus 1, which in this case is 10 minus 1, times that common difference of 3. So this is going to give me a 9. 9 times 3 is 27. 27 plus 2, you know what I'm going to say, my age. If you do enough of these note sheets, you're probably like, okay, actually, you don't even have to do these note sheets. I made that same joke the entire year. So now we can find this quantity. So what you're going to see, and actually I probably don't need to use my calculator, but let's just be safe. 10 divided by 2 is the 5, and then 5 times 31, we're getting 155 is the sum. So there are some people who are very stubborn and don't like to learn the formulas, but you will definitely need to have knowledge of them for problems that get a little bit more complicated. Now, if you look at the next problem, this is a problem that's a little bit more complicated. I'm saying evaluate, and there's a sigma. And remember, that means find the sum. But here's the problem. You have to start by subbing in a 4, then a 5, then a 6, then a 7, then an 8, and keep going until you get to 30, and then sum in 30, and add those all together. You'll see that this would take a very, very, very long time. So as a result, we need to use a formula that gets us there faster. Now, I said that you can use this sum formula when something is arithmetic. When you're dealing with sigmas, arithmetic means you have a linear equation right here. If this is not linear, you cannot use this formula. So because this is linear, what do I mean by linear? Y equals mx plus b. We have a slope times a variable plus some constant value. Now, because this is linear, we can find the sum using the formula we just learned. But here's the issue. First thing I need to know is the number of terms. Now, be careful. A lot of people take the 30 and they subtract the 4 and they say, oh, this is just 26 terms. But you actually have to take the top number minus the bottom number and then add 1 to that. And I'll show you why in just a minute. If I do the top number minus the bottom number plus 1, that's 30 minus 4, that's 26 plus 1. This is actually 27 terms. So we're going to be finding the sum of 27 terms. A lot of people get messed up with the sigmas, but just to show you, if I said just evaluate a sigma and it was n equal 1 and n equal, or I'm sorry, all the way up to 2, you would sub in a 1, you would sub in a 2. This is actually 2 terms, right? Because you would sub in n equal to 1, n equal to 2. But if you subtract 2 minus 1, do you see how that's only 1? And we just said it should be 2 terms. You don't just subtract top number minus bottom. You have to actually add 1 to that quantity. Okay, and here's another example. If you had a bottom number of n equals 0 and you sub that in, notice that you'd have to sub in a 0, a 1, and a 2. That's actually 3 terms in this situation. So you don't just subtract top minus bottom. You have to add 1 to this. And this is a very common mistake. So be careful with that. So we're actually finding the sum of 27 terms. And that's right there. Now, to find the first term, be careful. The first term is not always subbing in a 1. That's misleading. The first term is when you sub in whatever that bottom number is for the sigma. So in this case, finding a sub 1, the first term, is really subbing in n equals 4. because when I write out this series, the first term of this series would be with a 4 subbed in for n. So what I'm going to get is 2 times 4 minus 1, 8 minus 1. I'm getting 7 as that first term of this specific series. To find the a sub nth term, which in this case is the last term of this, notice that that's going to be when we sub in a 30. Now, again, don't get misled by the fact that there's 27 terms. That's not representing that a sub n term. So a sub 30 in this case is going to be subbing in, obviously, that last, or that value up on top. So we're going to sub in. And then we can get that 2 times 30 minus 1. So we get the 2 times 30 is 60 minus 1. We're getting that 59 in there. So that is going to go right here. So then we can use our formula. And then we can do the 27 divided by 2. And then we can multiply that by the, oopsies, times the 7 plus 59. So we get 891 as that sum. Definitely would not have wanted to do that by hand.